These are my gas law experiments. For my first experiment, I used a can of soda, boiling water, and cold water, and a pot. The process consisted in boiling some water inside a can until steam came out, then placing the can upside down in a glass with cold water. The effect was that the can started crushing up on its own. The reason why this happened is because the steam inside the can condensed into water really quickly, resulting in a very low pressure inside the can. Because the normal pressure outside the can is higher, the air ends up crushing the can. For my second experiment, I used food coloring, a bowl of water, a candle, a glass, and some matches. What I did was placing some water in a clear bowl, put some food coloring in it, then placing a candle inside and lighting it up. After that, I placed the glass on top of the candle. The result was that the flame slowly started to go out while water from the bowl started to come in with the glass. The explanation for this is that the pressuring is increased inside the glass by the heat of the flame. However, the oxygen inside the glass starts to run out because it's being consumed by the flame. This causes the flame to go out and thus the pressure lowers. Because the pressure wants to be the same as outside, the water is pushed inside the glass. Boyle's law states that the initial pressure times the initial volume will always be equal to the final pressure times the final volume. Charles' law states that the initial volume over the initial temperature will always be equal to the final volume over the final temperature. Similarly, Gay-Lussac's law states that the initial pressure over the initial temperature will always be equal to the final pressure over the final temperature. Avogadro's law states that the initial volume over the initial amount in moles will always be equal to the final volume over the final amount of moles. Finally, the ideal gas law states that the pressure times the volume will always be equal to the amount of moles times the universal gas constant times the temperature. Thanks so much for watching.